So, what if I told you that the key to building the robots of tomorrow, well, it isn't being forged in some high-tech lab. Nope, it's being discovered inside the chaotic, absolutely massive open worlds of video games. Today, we're diving into this incredible breakthrough AI that's learning to act like a human just by playing games. And trust me, its mission is way bigger than just getting a high score.
I mean, this really is the central challenge, right? We've got AIs that can write poetry and have conversations, but how do you get them to move from the world of text into our physical reality? How do you teach an AI to actually do things?
Yeah, because let's be honest, the ultimate goal for the most advanced AI, it's not just about mastering language, it's about mastering action. And that brings us right into our first section, where we're going to break down why that is such a massive, massive challenge.
And the fancy term for this is an embodied agent. Just think of it like an AI that's been given a virtual body inside a 3D world. It has to see its environment, figure out what's going on, and then decide what to do next. Exactly like we do every single second in the real world.
So you might be thinking, okay, why not just train a robot directly in the real world? Well, because our world is it's incredibly complex and messy. Training a physical robot from the ground up is super slow, it's expensive, and if it messes up, the consequences can be, well, let's just say they can be really messy. There has to be a better, safer way for it to learn.
And this is where we get to the really clever solution from the researchers over at Google DeepMind. Instead of putting a robot in a physical gym, they're putting an AI into a digital one. And that digital gym? It's video games.
Seriously, just think of it like a flight simulator, but for an AI's entire brain. Video games are this incredibly rich, interactive world where an AI can practice really complex skills again and again and again, and the best part, there is absolutely zero risk of it breaking anything in the real world.
So what's so special about games? Why are they the perfect digital gym? Well, look at a game like No Man's Sky or Valheim. These are huge, diverse open worlds. You drop the AI in and suddenly it's in this vast, unpredictable universe. It has to learn how to survive, how to gather resources, build tools, navigate. These are all complex, multi-step goals. And it has infinite chances to practice, with clear rules and zero real-world risk. It's pretty much the ideal training environment you could ever design.
Okay, so let's meet the star of the show, the agent at the very heart of this breakthrough. It's called SIMA. That stands for Scalable Instructable Multiworld Agent. And its newest version, SIMA 2, is, and I'm not exaggerating here, a massive, massive leap forward.
And just look at this timeline. It's wild. The first version was only unveiled in March 2024. Just 18 months later, bam, we get this huge upgrade. This incredible pace, it just shows you how critical this research is. We're talking about the race to build more general AI, and let me tell you, that race is really heating up.
So what's the big deal here? What's the difference? Well, the first SIMA was basically just an instruction follower. You could tell it, go left, or pick up that rock, and it would do it. Simple commands. But SIMA 2? Oh, SIMA 2 is a reasoning agent. You can give it a high-level goal, something vague like find water and build a shelter, and it figures out all the steps to get there all by itself. And this chart right here, it shows you just how dramatic that difference is. When you look at complex tasks, the kind with multiple steps, the original SIMA, well, it struggled. It succeeded maybe 31% of the time. SIMA 2, it more than doubles that, hitting around 70%. Folks, that's not just a little improvement. That is a total transformation in what this thing can do. So what's the secret sauce? What changed? It's simple. SIMA 2 got a far more powerful brain. It's been integrated with Google's flagship AI model, Gemini, and that gives it this incredible cognitive engine that allows it to reason, to plan, and even to explain why it's doing what it's doing.
Okay, so how does this all actually work? Let's peek under the hood and get into the mechanics of how this agent sees its world and makes decisions, because it's all designed to be a lot like how a human interacts with a game.
It's all happening in this constant loop. Step 1, it sees the game screen, just like we do. Step 2, it understands the instructions we give it. And this part is so cool. The instructions are multimodal. That means you could type, go over there, draw an arrow on the screen with your mouse, and maybe add a little fire emoji for good measure. And the AI gets the combined meaning of all of it. Then its Gemini brain gets to work and plans out the steps. And finally, it acts, using a virtual keyboard and mouse. It's literally playing the game just like a person would. Now this brings us to what might be the most important concept of all, zero-shot generalization. It sounds complicated, but it's simple. It's the ability for the AI to perform tasks in games and environments it has never seen before. It's the difference between just memorizing a bunch of moves and actually truly understanding what you're doing.
Here's a great example. It doesn't just learn swing a pickaxe in game A to get stone. No, it learns the abstract concept of gathering resources. So when it gets dropped into a totally new game and sees a tree and an axe, it can put 2 and 2 together and infer, okay, I should probably try harvesting wood with this, even if it's never performed that exact action before. It gets the idea.
All right, which leads us right into our next section where we connect all the dots. Because we have to remember, this was never, ever just about getting good at video games. This has always been about building the robots of tomorrow.
And this right here, this is the core idea of the whole project. The skills it's learning in these virtual worlds, planning, reasoning, adapting to new situations, these aren't just game skills. They are the exact same fundamental cognitive skills that a general-purpose robot is going to need to operate safely and effectively in our world.
And this table really breaks down that direct translation. You see a skill like executing high-level goals in a game? Well, that's the same cognitive muscle a robot needs to unload the dishwasher. Or how about conceptual transfer? That's what allows a robot to figure out how to use new tools on a construction site. Seeing and controlling things on a screen becomes pressing buttons on a real device. It's a direct one-to-one bridge from the virtual world to the physical one.
So all of this brings us to the future. We've got this incredibly powerful new engine for learning, so what comes next? And what are the big challenges that are still left to solve?
And to be clear, the researchers are very open about the fact that the work isn't done, not by a long shot. There are still some big hurdles. Things like giving the AI a real long-term memory so it can remember things across days, or letting it manage super long, complex projects. And of course, the big one, perfecting that fine-grained physical control and dexterity you'd need for really delicate tasks. So if there's one thing to take away from all this, it's this. SIMA 2 is not a game-playing bot. Think of it as the proof of concept for a cognitive engine. It's the foundational building block that's going to power the next generation of general-purpose robots, the ones that could one day help us in our homes, our workplaces, and everywhere in between.
And that really just leaves us with one fascinating final question. This technology is moving at an incredible speed. So as these agents start to make the leap from these virtual worlds into our own, what should we ask the very first general-purpose robots to do? What are the first truly helpful things we'd want them to help us with?